You're the CEO and founder of Ouster, and looking forward to our fireside chat today.
Likewise, thanks for having me.
Perfect. So for those in the audience that might not be that familiar with Ouster, do you mind taking a few minutes to introduce the company to us?
Sure, yeah. And I think about Ouster with really three pillars. So Ouster is a high-performance digital LiDAR company, and the three pillars that really set Ouster apart in the market are our digital LiDAR technology, kind of the underpinning technology that powers all of our products today, our differentiated strategy, diversified across markets. So we're focused on four key markets: automotive, industrial, smart infrastructure, and robotics. And then our proven ability to execute over the last 6 years. We've really distinguished ourselves against our public peer set, who all started around the same time, in our ability to ship product, gain customers, and achieve product market fit. So just touching on those three a little more, the digital LiDAR technology that underpins everything we do is the concept of integrating a complex electromechanical analog system onto a silicon chip. And this is what Ouster has done in LiDAR for the very first time. We invented the technology that allows us to incorporate a complex LiDAR system onto a single silicon CMOS chip, which is the story of Silicon Valley for the last 60 years, whether it's CPUs and GPUs or telecom infrastructure, or cell modems and GPS receivers, or digital cameras. Digital cameras being a great example of a sensor technology that is going through this unbelievable transformation of the last 20 years as it's digitized, and the combination of performance and affordability improvements to imaging technology through digitization has absolutely exploded the TAM for camera technology. So that now you can have the identical digital camera architecture running on a drone on Mars, and in your pocket, in your cell phone, and in your car. It's really fantastic how digital products are flexible across markets. And so we're bringing that same digitization of LiDAR, of a technology set, to LiDAR by putting LiDAR on a chip. And that brings me to the second kind of pillar of Ouster, which is this diversification across markets. So we see the opportunity for LiDAR sensing technology much more broadly than I think many of our peers that are in the market today. Again, we're focused on the automotive, industrial, smart infrastructure, and robotics markets. And what we're betting on is a global shift towards increasing levels of autonomy across all of these verticals. And I think there's huge numbers of proof points. And I spent a lot of time in the last 6 months educating the public markets about the broader opportunity for autonomy. And autonomy needs high performance, safety critical LiDAR sensors. And digital LiDAR is kind of uniquely positioned, just like digital cameras, to explode the TAM and actually be applicable across these different verticals. It really has the flexibility in terms of affordability and superior performance that allows a LiDAR sensor, the same LiDAR architecture, to play across these verticals. So that's really exciting. We can talk about some of the end use cases in each one of those verticals. And then the final pillar, the ability to execute on this vision. I really think Ouster is second to none here. We have over 600 customers today. We have guided to 33 to 35 million in revenue this year, 26% gross margins, which we've been able to achieve the last 2 quarters with best-in-class gross margins in the entire industry, the only positive gross margins on product hardware in the industry. We shipped almost 1,500 units last quarter, about 1,000 units the quarter before. So shipments are up almost 3x year over year. We're having a fantastic year. We've also been able to outsource to manufacturing. So we're the only company that has outsourced manufacturing to a great contract manufacturing partner, Benchmark Electronics Thailand. So, all of that combined just shows we have great product market fit. We've shipped multiple generations of our product now, and have reached, a tipping point where we just see digital LiDAR being increasingly affordable and performant, even though it's in a kind of a leadership position today. So I'll pause there.
Excellent. It's a great overview. Yeah, you mentioned doing a lot of investor education to the public markets on LiDAR over the past 6 months. A common question that Josh and I get is now that there's more than half a dozen of you out there, is how do we think about a framework to differentiate all of the different LiDAR companies? Obviously, you were at a previous LiDAR company. You've now started a new one. You've seen what works, what doesn't work. You've made a choice to go down the silicon path. But what are some of the key variables, as similar to the camera analogy you made of field of view, long range, short range, etc.? Those are some of the basics for LiDAR. But what are some of the really nitty gritty things that investors should focus on to differentiate the bevy of players out there?
Well, I always try to focus on things that don't require a PhD in physics to interpret. I think it's really easy in this industry to try to hone in on and try to understand the technology at a really low level and make a bet based on, I don't know, some nuanced argument about physics, when in reality there's so much diversity of approach in between the players that it's very hard to actually come back with a credible conclusion. So I looked at things like technology trends that are driving the companies. So they're really what Ouster is betting on is Moore's law. We're betting on aligning our product with Moore's law, an exponential scaling law that is second to none in the world. There's nothing like it, and there hasn't been anything like it for 60 years. And that's really the reason that digital products in Silicon Valley has dominated so many industries with that same technology set, is because it is an exponentially improving and increasingly affordable technology. And so I look at scaling trends and how that's driving an industry. And I also look at what kind of existential bets or risks are implied by the business model of the companies. And so by design, I have put Ouster in a position where we don't have to be right about whether robotaxis or level 3 ADAS or level 2 ADAS or level 4 ADAS or robo trucking or any of these markets could evolve faster or slower than the other. But I don't have to be the oracle and guess right. We haven't made a bet on one industry. We're selling pickaxes to everybody in the gold rush. Literally everybody, and we have the products that are flexible enough to actually make that possible. So I think that kind of honing in on how much risk is there in the business model. If the bet is wrong, do you have a business? And how long, the last thing that I would look at is how long do you have to wait to know if you've made the right bet? Because I think that there's a lot of delayed revenue in these industries, when the reality is that there are billion-dollar LiDAR markets today. For instance, in industrials, there's almost $1 billion in industrial grade LiDAR sensors that are sold today, and that's revenue to be had today, and a massive business that can be built today. So those are maybe not quite the answer that you're looking for, but that's how I think about Ouster. There are lots of technology kind of ways to show that are important, but trends and bets and how they're going to play out.
That's helpful. Maybe just on the two different types of LiDAR that you're producing today, solid state, mechanical, can you just touch on the different applications for each? I assume when aesthetics don't matter, mechanical's fine, maybe more of those industrial applications that you touched on. I think that's where you started, and then you've obviously got solid state ramping up nicely. But maybe just touch on the two, and then how do you think about the cost curves for both? Do we reach a point where solid state just subsumes mechanical? That hasn't happened in the disk drive space. We still have both. So I'm not sure if it happens in LiDAR, but what's your perspective there?
Yeah, and this is another place where we've taken a very different approach than our peers of what our product portfolio actually looks like. So, a hallmark of analog technology is that it's purpose-built for a single application, because it just isn't flexible enough and performant enough to be applied across. You have to make something so narrowly defined for it even to have a chance in the market. And you can look at a purpose-built analog computer from the 50s as kind of the canonical example, but versus general purpose computing. So what we've done is we've built a platform of products, a product suite that spans scanning systems and solid-state systems. And we supply today over 75 different configurations of our scanning systems even into the market, with the idea that customers can come to us and select the right sensor and kind of mixture of performance and feature set and price point that works for their application, versus us trying to dictate what product is necessary in each one of these applications. And so building a product platform on a common technology architecture is what we've done, and it's what most, it's what silicon companies do. And it's really powerful when you can get to that point, because again, then you're not having to place a bet on your product team, perfectly defining perfect product for one application, and then going and doing that again. So on the question of scanning versus true solid state, we're going to be supplying both to the market for the foreseeable future until customers stop buying one or the other. And I think that there's a much longer tail to these scanning mechanical systems than people expect, just like the disk drive industry. It's really hard to beat a mechanical disk drive on bits per dollar at the highest capacities. And kind of in a similar fashion, it's going to be very hard to beat the performance per dollar of a spinning LiDAR sensor if you're willing to kind of accept the form factor of a spinning LiDAR sensor. So solid state LiDAR sensors will be lower cost and smaller in a lot of cases, and that's the benefit. But you're going to have to use more of them blanketed around a vehicle, versus maybe if you're willing to put one spinning LiDAR sensor on the top of your roof, that can do the job of 5, 8 solid state LiDAR sensors. So there's going to be this trade-off for a very long time that's going to keep both in play. And we're happy about that. Like, that's great. We're supplying both.
Got it. Maybe just a follow-up on that, and I'll turn it back over to Josh. Is I assume the majority of the revenue in the near term is scanning, and over time, as you move to the middle of the decade, have you guys given a sense of a scope? 2/3 of the revenue in the middle of the decade based on your targets is solid state, or how will it be apparent to investors as this transition plays out?
I expect at some point to start reporting the revenue split between the product families, but we're not going to do that. Like in our current, we've tried to build in conservatism into how we think about the business, and what we know right now is the market reception and opportunity for the scanning systems will release, and that's what we're really modeling the business on, is just scanning system opportunities, with a very small contribution in the next 5 years from the solid state. Now, I think there's upside to the solid state sensors, that we could drive significant adoption, more than maybe we're planning. And at the point that it becomes kind of a material impact to our revenue, we'll start reporting it and splitting it out. And I think you see companies like Apple even doing this, where they didn't report on watch revenues for the first 5 years of the watch because it just wasn't big enough. And then it got big enough and they started reporting it.
Got it. Josh, I'll turn it over to you.
All right, thanks, Jeff. And thanks, Angus, for all the detail here. I like how you phrased it with the optionality of your customers and applications. You do have to make decisions on the design factor, though, where you have to make bets. Can you talk about some of those decisions within your SPAD array and your VCSEL and maybe your processor as well, and how that differentiates your actual product performance to win a broad range of applications?
Yeah. So we are still constrained by the limits of the technology, the semiconductor technologies that we use that underlie the product, and we've set hard limits on things like form factor and power draw in our system, and because I think ultimately those are things that dictate how broad the TAM can be. If you know that the raw performance of the sensor is going to increase over time exponentially with Moore's law, which is a fact at this point. We've already doubled the sensor performance in the last 2 years through chipset tapeouts. If you know that that's going to continue, then we wanted to define a product envelope, a form factor, and a power draw that's small enough and low power enough that it can go in a car, it can go in a drone, it can go in a traffic light, it can go in a small mobile robot, and all those same products can be used, or one kind of product can be used across all those applications. So so I think that kind of underpins, those are the constraints that we work on, and that kind of then flows out, like how big our chips can be, how high of a resolution they can be. But the good thing is, it turns out we can be the highest resolution sensors on the market and be the smallest and the highest and the lowest power draw. And so digital technology, even though we started with some pretty tight constraints, the digital technology allows us to be best in class in like resolution and range and field of view, despite those constraints.
And I guess following up on that, I mean, from a semiconductor perspective, CMOS is the obvious choice because of the economics. Why are you guys, I guess, how are you guys able to do it, and why have your peers not gone after using a more standard architecture like CMOS?
Yeah, and well, there's always a point in time. You have to be at the right place at the right time with the right enabling technology to transition an industry to digital. Putting a LiDAR sensor on a digital chip is not just about putting some pixels on a chip. In our chips, we have over 100 million transistors worth of digital logic. We're really trying to condense down every last bit of a LiDAR sensor onto one silicon chip. That's the most important thing. So originally, I think 5 years ago when we started all this, basically our founding IP enabled us to use a relatively early version of the CMOS detector technology that was pretty low performance when compared to the mature analog detector technology that was out there. And so we had to kind of claw back performance with a bunch of fundamental breakthroughs at the system level and at the algorithmic level in order to build a digital LiDAR that was performant 5 years ago. And so now at this point, I think my expectation is there will be more and more digital LiDAR companies that are starting to try to follow our path as it becomes increasingly that better technology has made it easier, quote unquote, to build a digital LiDAR that can perform at all. But we have a 5-year head start on building these sensors, and our plan is to maintain a leadership position just through aggressive tape outs, which is how semiconductors industries like this play out. We're going to have competitors, but they're just going to be following 2 to 5 years behind us.
Mm-hmm. And then, can you talk about your ability to offer 75 unique configurations? How are your customers? Practically, how are your customers using this? Are a lot of them? And how does that improve your economics? And if I'm understanding correctly, you're able to do that using pretty much the same components, changing some of the software and adjusting the lenses. Am I understanding that correctly?
Yeah, that's accurate. So just like a digital camera, you can change its capabilities by using the same image sensor, but putting different lens sets in front of it. That's one of the things that we do. So it's a really efficient way. We use all the same semiconductor chips, but then put different lens sets in front, and you get very different capabilities. So fisheye sensors that might be used on a slow-moving warehouse robot that needs to see high up on shelves and right down to the floor, versus a telephoto type lens system that is used for a highway driving robo truck. And so that's one way. But the other way is through customization at the silicon level, turning on and off features in our silicon in the same way that to unlock different feature sets and performance levels for our customers. So we can segment the market there really efficiently. And that's something that semiconductor companies do commonly. Like Intel might tape out a single core i5 or core series processor, but then they'll firmware limit it or microcode limit it to being an i5, an i7, an i9, having different levels of cores and things like that. So we do that kind of silicon binning as well.
So that's helpful. Then I guess we've asked this question to a number of your peers, but if we think about what a sensor does, is you're gathering data and then there's some level of perception done either on your device or you feed the data somewhere else and somebody else does it. So I guess, are many of your customers using your software for perception? And where do you ultimately view yours and your peers in the overall perception, I guess, food chain?
I think that you can look at the camera industry to see how this can play out. Ultimately, LiDAR sensors, in my view, a digital LiDAR sensor should just be a better camera. It can be a safety critical, all-weather, perfectly performing version of a camera that gives you depth as one of the fundamental layers, but it can give you imagery as well. And in the camera industry, you start with, you've got to make best-in-class image quality and improve that, and that's what's happening with digital LiDAR sensors and other LiDARs as resolution range goes up. But then cameras started incorporating co-processing chips directly in the camera hardware that does AI perception co-processing. And I think that's the progression that we'll see in LiDAR as well. It seems it's obvious and inevitable, given how many customers need some sort of perceptive layer in these devices. There's also another route, though, and we're already supplying software development kits that allow our customers to build perception or give them the building blocks of perception and build software much more easily and with lower friction than if they were to start from scratch. And I think that in order to supply and be a best-in-class company, we need to have the best hardware, but also the best development tooling in the industry. So we just last quarter introduced our software development kit, and I think we've had several hundred customer downloads at this point, which is great to see.
Great. Last one for me, I'll turn it back to Jeff. I guess, given the breadth of your customers and engagements, can you talk about, I guess, how they differ between auto and non-auto, since so much of the conversation in the space does tend to revolve around auto, for better or worse?
Yeah. So what we've commonly, people think that auto is the most stringent set of requirements, but we have customers that have more stringent requirements than auto. These will be kind of functional safety requirements even. So mining customers, for instance, operate in hotter, colder temperatures with worse environmental conditions than on-road driving, and higher shock and vibe and things like that. But regardless, what we've done is we've mapped out the outer envelope of stringent requirements across all of our customers. So we've taken the superset requirements and we're designing to that. And so by definition, that has allowed us to design sensors that are automotive's grade, but also SIL 2 certified for the industrial sector. There's special certifications in smart infrastructure and so on and so forth. So I guess that's just like product philosophy. We're designing to this superset of requirements that do encompass automotive. And in a lot of cases, automotive is the most stringent requirement of any industry, but it's not always the case. And in terms of how the customers behave, I think that was kind of the core question. Yeah, and
how your engagements differ.
Yeah, I mean, so automotive for us is actually 4 sub-verticals. So it's consumer ADAS, which is traditional automakers and tier ones, and they function very differently than basically everyone else in the list, which are robotaxi companies, robot-trucking companies, and shuttles and buses, kind of automated shuttle and bus companies. And so there is a big difference in the behavior and the timelines of any consumer ADAS opportunity. It's strategic sales. There's incredibly long design cycles, and revenue is going to come in 3 to 5 years. And the price points and the expectation on what we're delivering are, well, ACE will be certified functionally safe devices at hundreds of thousands of unit quantity in 3 to 5 years. That engagement is just fundamentally different than how we engage with the other 3 in auto or a lot of our other customers. Where they're able to deploy the systems much sooner and at lower levels of certification. That's not always the case. There's plenty of large-scale OEM industrial customers that make safety-critical heavy equipment that also are on a 3 to 5 year production cycle, and we're going through a very similar kind of automotive-style engagement just for the industrial space. But that gives you a sense for some of this.
No, thank you, Jeff. I'll kick it back to you.
Yeah, thanks, Josh. Yeah, we had a Safe AI who's doing mining equipment at the conference earlier in the week, and certainly a lot of challenging conditions, as you mentioned, for situations like that they're working on. Maybe just a follow up on the software question that Josh asked. One of the I've covered the tier ones for quite some time, and one of the challenges that we hear from them, in particular with the camera analogy, is that they get locked in with the Mobileye sort of ecosystem because of the pairing of hardware and software. And so I just want to be clear, as you mentioned, there's auto cycles every 3 to 5 years, and that seems to be in an EV world accelerating as people share platforms. I think the life of a car platform will just get faster. How do you, assuming you have the best sort of killer hardware, is there an ability to sell hardware only and just win that way? Or with your hardware, do you have to buy some elements of the perception stack as well? Passenger car, I guess, is the impetus of my question. I would think the two simples, the pluses, the Kodiaks of the world, don't need anything of your software, but maybe I'm also wrong. But we also had Plus and Kodiak at the conference, who I think some of those are customers of yours as well.
That's right. Yeah, they are. And so there's plenty of customers that are sophisticated enough that they don't need software from us. But there's an even larger list of customers that have very little capacity to develop autonomy software themselves. I mean, think of tens of thousands of industrial companies that are either small or just like operating in a legacy mode where they have very little ability to build the software on top of our hardware. So there is immense opportunity. One of the things I love about our diversified business is like that you can identify these customer sets that where it's running downhill to supply them more value add on the software side. On the automotive customers, it's tricky. I think that tier ones have a vested interest in not allowing new players to supply software. That's their business, and they have a great proof point of what not to do in Mobileye. Well, Mobileye is really, to their credit, I don't know if steamrolled is the right word, but Mobileye has injected themselves as a tier one and taken value away from the traditional tier ones. And I think they're dead set on not allowing that to happen again. And also OEMs themselves are trying to identify what part of the technology stack they want to maintain control over and not pass off on to a tier one even anymore, let alone Mobileye. So there's definitely an opportunity to sell margin positive hardware, best in class hardware. I'm really excited about that. There's no question we're going to do it. On the software side, there may be an opportunity to supply software, but it may be table stakes. It may be like a way to win the business because you have great software that you can supply alongside the hardware, but you don't get paid for it, which is true of most automotive sensors today, to be frank. Like a radar sensor, that's kind of how it works. And then there's an unlikely but scenario where some new hardware companies like us could break into generating significant software revenue, but I think that's an unlikely scenario and one that will take a long time to transpire if it does.
I've only got about 1 minute left, but that's what I appreciate about your perspective is that when you went public in your SPAC merger deck, you clearly called out that your automotive gross margins were considerably below the rest of your business, and you have a bunch of other things to highlight growth. But just remind the audience, what was it, 25% is the assumption for auto and north of 40 in broad
That's
terms?
right. Yeah. I mean, we have lower costs than I think any other technology, and yet we're also projecting a lower margin, specifically in automotive, 25%. That's right, than our peers. And this goes back to looking at what kind of bets are companies playing. I think it's really important to look at this. What if we're wrong about our margin expectation and it's actually 50%? That's great. That's super for us. I'll be really happy. But I want to start with a conservative assumption. And what I see from a lot of our peers is 50, 60% margins in auto. And if they're wrong, then they don't have a business. If it's actually much, if they're wrong, they may not have a business. And knowing if they're wrong is going to take 3 to 5 years. And that's the other thing that I look at. I'd much rather be called on my assumptions in the next year or two, and that's why I mean, we've been trying to really focus on the operational stats about the business today, not hypothetically in a couple of years. I don't know if we lost Jeff.
Oh, it looks like we lost Jeff, but I think we're out of time anyway. Thank you, Angus. We appreciate you joining us and for all the details. Thanks.
Yeah, thank you. My pleasure.